Hello. Today we are going to do a lab called the ups and downs of thermometers, and we're going to be investigating this question: what makes the liquid in a thermometer go up and down? Okay, so what you will need is a thermometer, a magnifying glass if you have one, and then just some hot and cold water. Now, if you're at home and you have a thermometer that maybe you put in your mouth if you're sick, that'll work for this. Or maybe a thermometer that you have outside if you can detach it and use it for this. If not, don't worry about it. You'll be able to watch this video and get enough information to be able to answer the questions. And then when you come back to school and you see me again, we can certainly set you up with the equipment to be able to walk yourself through this lab. All right, first you are going to excuse me, look closely at the parts of the thermometer. Okay, it says look closely at your thermometer. Now I brought two. I've got one that's in Celsius and one that's in Fahrenheit. The ones that we have here at school, we kind of have a mixture of them. So some of you might get a Fahrenheit one and some of you might get a Celsius one. Just make sure that you're looking to see which one is which. Okay. It says read the temperature by having your eye at the same level as the top of the red liquid. Okay, so you are going to match up where the red liquid in the thermometer is. Now I don't know if you can see this. Let me see if I zoom in. You can kind of see where the red is right there, right? If we turn this towards the screen, you can see that the red liquid is at about 88 degrees. 88 degrees. Each of those little hash marks is worth 2 degrees. Okay, and this one is in Fahrenheit. All right, so you can see right there that that red liquid all coming out from this bulb down here is at about 88 degrees. If we go back to the lab, it says use a magnifier to closely look at the thermometer from the front and from the side. Look at the bulb and the thin tube that contains the red liquid. Okay, so if you've got a little magnifying glass, you can check that out inside. You can see that there is the red liquid is down here at the bottom, and there's a really thin tube that goes all the way up the length of the thermometer. Number 4 says, put your thumb or finger on the red bulb to see if the red liquid moves in the thin tube. Okay, so I'm going to zoom this in again, and we'll see if you can actually see that on here. If I put, oh, there we go. If I put my fingers on that, you should see that red line. Now it's moving past the 90-degree mark. Do you see that? And if I take my hand off of the red bulb, see I got my fingers right down here on the red bulb. If I take my hand off, it should go down, although it might be a little bit gradual. You can see it start to decrease now. It's going below 90 now. All right, go back to the lab here. Okay, part B says observe the red liquid in the thermometer when it is heated and cooled. Okay, so we are going to place the thermometer in hot water and watch the red liquid. Keep it in the hot water until the liquid in the thermometer stops moving, and record the temperature. All right, so I'm going to zoom in again, move my computer away. I have some beakers here. I'm going to pour some hot water in this one. Very hot and steamy. And I will see if you can see the red line. You can see how fast that red line is moving up. It is now, this one is in Celsius, I believe. Oh! It is actually in Fahrenheit. Okay, so the temperature is now 135. It's approaching 140 40, but it looks like it has stopped. So 136, it looks like 136 degrees Fahrenheit. Okay, back down here. So you would record your temperature right here. Then it says now put the thermometer in cold water. Keep it in the cold water until the liquid stops moving and record the temperature. All right, we'll switch this back here. I'm going to pour some icy cold water in here. And I'll see if I can get you to watch the red here. It's hard to line it up. You can see the red line going all the way down quickly, right? It is now at about 66 degrees, 62, and it's stopping right below 60, maybe at about 58 degrees. All right. The next questions here are based on what you observed there. Based on what you know about the way molecules move in hot liquids. Now recall yesterday's lab. You know, how were those molecules moving? Were they moving rapidly and hot? Or were they moving slowly and hot? And when they move rapidly, do they spread far apart or are they clumped close together? Okay, so think about what we learned in yesterday's lab and explain why the liquid in the thermometer goes up when it is heated. Okay, number 2, based on what you know about the way molecules move in cold liquids, explain why the liquid in the thermometer goes down when it is cooled. Number 3 and 4 are just thought questions. Why do you think that the tube that contains the red liquid is so thin? Okay, so we have this glass tube, and then inside that there's that tiny little tube that holds the red liquid. Why do you suppose that is so thin? And then what do you think the purpose of the larger outer tube is? Okay, for this last part, I'm going to bring you to this video here. Play the video. You can see that at room temperature, we've got a level of a thermometer right here. We've got molecules moving and bouncing and bumping into each other and moving past each other. Now if we cool that down, you should see this level go down. Well, if we zoom in to what's happening to the molecules in this liquid, you will see that they are clumping pretty close together, right? Clumping pretty close together. And they slow down a little bit. Bring it back to room temperature. What do you think is going to happen when I hit the hot button? Well, you should know what's going to happen here. But why is that happening? You will be able to explain it once I hit that and you look in this little circle. Okay, so the level has gone up. And look at how rapidly these are moving and how much space is in between them. Okay. So this last part here, it says you saw the animated molecular model of a thermometer at different temperatures. Now you will draw your own model. The drawing shows 2 close-ups of a thin tube and a thermometer, like the one you used. One picture represents the thermometer in hot water, while the other is the thermometer in cold water. Based on what you know about the motion of molecules in a liquid and what you saw in the animations, draw in the circles to represent the alcohol molecules in the liquid. That's what this is in here, red alcohol. Molecules in the liquid in the thermometer. Try to show the difference in distance between the molecules when the liquid is hot and cold, and use motion lines to represent their movement, both fast and slow. Okay, so if you were going to draw a fast moving molecule, you would put those motion lines, those 3 little motion lines would show that it's wiggling really rapidly. And a slow moving molecule, you would just put 1 little motion line to show that it is still moving, but it's moving much more slowly. And then also, don't forget to include the distance between the molecules? How is that different in hot and in cold? Alrighty, have fun with this lab. When you are done, go ahead and turn it in. Again, if you are trying to draw these in and you don't have the ability on your iPad to actually make the drawing in this document, that's fine. Just make a drawing on a piece of paper. And then when you turn this in, also turn in the picture of what you drew. Okay, I will talk to you soon.